Last thing we're going to work on is solving rational equations when we have powers of 2, quadratics, in our denominator. So let's go ahead and look at this first one here. I see an x squared, a 5x squared, and a 5x. And looking at that, my common denominator is going to be 5x squared. So for the first one, I'm missing a 5, so I'm going to multiply top and bottom by 5. Second one, I have everything I need. I have a full 5x squared. And the last one, I have 5x, and I want it to be x squared, so I need to multiply by another x. Note that I don't need to square the top and bottom. I need to multiply by one more x on top and bottom. Squaring the top and bottom is never going to be a valid thing you can do when you're changing an expression. So now I have something over 5x squared, something over 5x squared, something over 5x squared. And if we remember how our rules were working out above, we can multiply both sides of the problem by 5x squared, and seemingly magically, all of our denominators will go away. We've multiplied through and we've canceled them out. So we're left with 5 times 1 is 5 equals 3 plus 1x, or x. Subtract 3 from both sides, and we get x is equal to 2. Now here's what's weird about these problems, is whenever you have squareds going on in the problem at some point, you need to do something called checking for extraneous solutions. So we need to go back to our original problem, and we need to plug that 2 back in everywhere we see an x. So let's go ahead and try that. Everywhere we see an x. So if I plugged in an x squared down here, that's going to be 1 over 2 squared, or 1/4. So I'll write that right here. I have 1/4 equals, and then 1 over, or 3 over 5x squared. So 5x squared would be 5 times 4, or 20, so 3/20ths, plus 1 over 5x, and if x is 2, so 1 over 5 times 2, 1 over 10. If I get myself a common denominator on this side, I'm going to have 3 over 20 plus 2 over 20, multiply top and bottom by 2, I would get 20ths for both of these. That's 5 over 20, and 5 over 20ths is equal to 1/4 if you reduce it, divide top and bottom by 5. And that's what we expected it to equal. So it does work. So it is not an extraneous solution. X does equal 2. There will be times where you get the answer, you plug it back in, and it will not work. It will give you a incorrect answer, and that seems to come up even more with negatives, but it can happen a lot of times with positive numbers as well. One more example we can work on is going to be number 12. When we look at our denominators, I have an x squared, a 2x squared, and an x. My largest number is a 2, and my only number is a 2. My highest power of my x's is x squared, so 2x squared, which means multiplying top and bottom of this one by 2. Notice how I put parentheses on that numerator because there was addition or subtraction going on. I didn't want to miss anything. I have everything I need on this one, and this one needs both a 2 and another x. So I'm going to multiply this top and bottom by 2x. We're getting used to our drill where every time we get like denominators all the way across, we can get rid of the denominators, and what we're really doing is multiplying both sides of the equation by 2x squared, but the shortcut in our heads might feel like we're crossing it out once we get them in common. We distribute what we have here, so we get 4x minus 4 plus x plus 5 equals, and we have to distribute this 2x to the other 2x, so 2x times 2x would be 4x squared. 2x times 4 would be 8x. And now we need to start combining things together. Whenever we have a squared term and it doesn't look like it's going to cancel out, we want to, instead of getting x on one side and numbers on the other, we want to get everything on the same side. So in my case, I'm going to say let's get everything to the right side of the equation. So to do that, let's combine our like terms first to get 5x, and our like terms negative 4 and 5 to be a positive 1. Then I'm going to subtract 5x from both sides and subtract 1 from both sides, and I'm left with 0 is equal to 4x squared plus 3x minus 1. Now to factor this is actually a pretty complicated factoring problem. We have to do the three-step factoring, if you remember way back from section 7.4 when we were doing different factoring techniques. This is one where there's nothing we can factor out all the way across, so we can't do the quick one-step factoring. We need to do this multiple step process and see if we can remember this. So we have 4 times negative 1 is negative 4. And we want two numbers that multiply to negative 4 and add to positive 3. So we have 1 and negative 4 or 2 and negative 2. These add to negative 3, so let's switch our signs so that they add to positive 3. And we're going to use that to rewrite this problem here. So 0 is equal to 4x squared, and we're going to split that middle term up into minus 1x plus 4x minus 1. And these two terms are both going to be, two chunks are going to now factor. So we have an x in common that we're going to pull out front, and leaving us with 4x minus 1. Over here we have nothing in common, so we're going to put a 1 out front and do 4x minus 1. Since the groups are the same, we take the 4x minus 1 out front and the x plus 1, the leftovers, as a group. And now we have it fully factored. 0 is equal to all of that. And since we're trying to find solutions, what we want to do is we want to say what's going to make these go to 0. It's kind of like solutions to quadratic equations that we were looking at last unit. In fact, these are solutions to quadratic equations, and it's similar in a lot of ways to when we looked at excluded values. So let's start with the second group because it's a little bit easier. The number that you could plug in for x into the x plus 1 group would be negative 1. That would make it go to 0. For this one over here, 4x minus 1, a little less obvious, so let's write it out. 4x minus 1 equals 0. Add 1 to both sides. 4x equals 1. Divide by 4. X equals 1/4. So 1/4 is going to be the other solution. So after all that work, we have two answers, 1/4 and negative 1. The part that might be a little frustrating at this point is we don't know if these answers are for sure going to work. There's a possibility that these answers are no good. We need to plug them back into the original problem to make sure. We're going to use our calculator here. You can use an iPad calculator or a standard calculator to make sure that we can check our answers, our solutions, to see if they are real solutions or if they are extraneous. That 1/4 as an answer, we're going to use 0.25 in our calculator when we check it. I think that'll be easier to work with. Whenever we have a fraction such as 2x minus 2, the top part of a fraction, we're going to use parentheses for that. So 2 and x is going to be 0.25. Minus 2 is all on the top of the fraction. So 2 times 0.25, 2x minus 2, and then that's going to be divided by our bottom of x squared. So I'm going to do parentheses 0.25 squared and throw that in parentheses on the bottom. So now that's my first fraction. I'm going to do plus. I have x plus 5, so I have 0.2, don't forget our parentheses, plus parenthesis 0.25 plus 5, so x plus 5, close my parenthesis, divided by 2x squared in the denominator. So in the bottom, 2 times 0.25 squared, and the order of operation should work fine there. And I'm going to hit equal because that's one side of the equal sign, and I get 18 on the left side of the equal sign. On the other side of the equal sign we have 2x, 2, and we said x is 0.25, so 2x plus 4, close my parenthesis, divided by the bottom, which is just going to be x. So 0.25, wrap that in parentheses, get in that habit of wrapping the top and bottom of every fraction in parentheses. And that is also 18. So that means if both sides are equal to the same thing, both sides are equal to 18, that answer is a real solution. It is not an extraneous solution. It is a real solution. Our other answer was -1. So I'm actually going to go and tap on the original, oops, too many times. I'm going to tap on the original problem that I typed in. You have to kind of tap a little bit underneath it, it seems like, in order to change out every time I see a 0.25, I'm going to replace it with a -1. So I'm going to replace the 0.25 squared with -1. But when I do that, I'm going to make sure I throw an extra set of parentheses in there. And the reason I would throw an extra set of parentheses around a -1 in this case is because I'm about to square it. Otherwise, we just kind of go through and replace all of those with the new value of x that I'm looking at. Again, we're squaring here, so I want to make sure that I replace it with parentheses and a -1. And then get this last one here. And I get -2 on the left side of the equal sign. Let's bring up my right side of the equal sign problem, and let's go ahead and replace all my 0.25s with -1s over here. And I get -2 on that side. So both of these solutions will end up working. Both of these are actual solutions to the problem. Neither is extraneous. Good luck with the remaining problems. Take your time and make sure that you check your answers, preferably using your calculator, to make sure that you don't have any that are extraneous.